All right, so number 5, convert from standard to vertex form. So first thing we need to do is find the vertex. So the x coordinate, so let me start here. A is 1, B is -4, and C is 0. Okay, there's no constant term added to the end, so that tells us C is 0. All right, so my x coordinate, opposite of B, all over 2 times A. So that gives me +4 divided by 2. So the x-coordinate, my vertex, is +2. When I plug +2 back into my original, I get 2 squared is 4 minus 8, so I get -4. Okay, so y equals my A value, x minus the x-coordinate of my vertex, quantity squared, plus k. All right, so just as a reminder, I'm using A, H, and K. All right, vertex form, y equals A, x minus h squared plus k. All right, number 7, A is equal to 1, B is equal to 4, C is equal to +3. X coordinate, my vertex, I'll use h here. Opposite of B, divided by 2a, -4 divided by 2 is -2. When I plug that in to find, let me change that to a k, +4 times -2. Please be aware of your order of operations. 4 minus 8 plus 3, -4 plus 3, so that gives me a y coordinate of -1. So I have my value of A, my value of H, and my value of K. Y equals A, x minus -2, so that becomes a positive. Quantity squared, and then -1 at the end. Now technically, if A is 1, you do not need to write that in there. So both of these forms, if you wrote it like 5 or 7, then you're in good shape. All right, now the graphing. So number 11, convert from standard to vertex, then graph. Okay, so A is 1, B is 6, C is 5. Vertex, opposite of B, divided by 2A. So the x-coordinate of my vertex is -3. The y-coordinate of my vertex, all right, -9 plus 5, so I get a -4. So now when I look at my vertex form, A, x minus -3 squared plus k. All right, so like I said in the video, you need 3 points to graph. I'm going to start with my vertex. So -3, 1, 2, 3, -4. That's where I'm going to put my vertex. From my standard form, I know that the value of C is my y-intercept. So 0, 5, 1, 2, 3, 4, 5. That's my y-intercept. Now I'm going to use my line of symmetry to get that third point that I need. So if my y-intercept is 1, 2, 3 units away from my vertex, then I'm going to have 1, 2, 3 units away. I'm going to be at the same y value. So there are my 3 points, even though it doesn't look great. Now when you check your work, if you picked another value to plug in, that's totally fine. Just make sure that you plugged it in properly, and it would be a point that falls on the graph that I have there. I also know, as a quick check, A is positive. So when A is greater than 0, I know that my parabola needs to open up. All right, number 12. A is -1, B is +4, C is -1. All right, so the x-coordinate of my vertex, opposite of B, divided by 2a. So -4 divided by -2. That gives me an x-coordinate of +2. Now, I cannot stress enough, the order of operations has to be correct. I square 2 first, then I take the opposite of that. So negative 4 plus 8 minus 1, that would give me positive 3. So the first direction, the vertex form, I do need that negative sign or the negative 1 out front of my set of parentheses. X minus the x coordinate of my vertex, quantity squared, plus k. Okay, so I'm at 2, 1, 2, 3 for my vertex. I know that my y-intercept is at the point 0, negative 1. So that's going to be here. So this is going to be a bit tighter than the other one. So my y-intercept is 1, 2 units away from my vertex. So 2 units in the other direction will be the third point that I need. A is negative, so when I go to sketch this, it verifies that my parabola is going to open downward. All right, and then lastly, number 16, A is equal to negative 2, B is equal to positive 12, and C is equal to negative 21. So just looking at this, I automatically know I'm not going to be able to plot my y-intercept as one of my points. Okay, so we're going to have to do something a little bit different. All right, so the x-coordinate of my vertex, I have the opposite of B divided by 2A. So that gives me negative 12 divided by negative 4. So my x-coordinate is positive 3. My y-coordinate, so wherever I see x, I'm going to replace that with positive 3. Grab your calculators, verify. I got k to be negative 3. If you did not get that, use your calculator and plug in exactly as I have written with the parentheses and everything. All right, so first vertex form, A is negative 2. X minus the x coordinate of my vertex, quantity squared, plus k. So k is negative 3, so I'm going to put that in as a subtraction. All right, I have 1, 2, 3, 1, 2, 3, 1, 2, 3. All right. Now, I talked about this in the previous video. So now let me think about a little XY chart here. If my vertex is at the point 3, negative 3, I'm going to go 1 unit below my vertex. And I know because of symmetry, 1 unit above my vertex, they're going to have the exact same y value. So in order to get those points, I'm just going to stick with 1. I'm going to look at x is equal to 2. So when x is equal to 2, I want to get what the output would be. And again, why do I need this? Because I can't plot 0, negative 21. All right, pause the video, plug that into your calculator, get an answer for me. All right, I got y is equal to negative 5. So I know that 4, negative 5 will also be a point on the parabola, again, using my symmetry fact. So I'm going to plot 2, negative 5, and 4, negative 5. Those are the 3 points that I need. A is negative, so it verifies that I have a downward facing parabola. And there are your 5 solutions to the worksheet.